So we're going to start by reviewing how to solve equations using additive inverse. Additive inverse just means to do the opposite operation when you go across the equal sign. So if your equation has a problem in it where they tell you to add, then your additive inverse would be that you would need to subtract to get it to the other side of equals. Don't forget that you have to do that for both sides. The same thing goes with subtraction and addition. These two flip-flop because adding and subtracting are inverses. So if they ask you to subtract, you would want to add to get to the other side of equals. Both of those happen in additive inverse. What we're going to do is take a look at some like 4 itty-bitty examples just to get your feet wet. We'll begin. This is 18 out of the book. So from this section, I'm pulling problems right out of the book. This is number 18, just as a model problem to get you guys started. So if you notice, we're going to solve for z. And in order for us to solve for z, you got to get rid of the positive 9. So again, if you've got an addition or a positive, you need to subtract to get it on the other side of equals. So what you would do is you would do minus 9 on this side, go across the equals and do minus 9 on this side. You're going to draw your line and cancel out your positive and your negative. Positives and negatives cancel out, not positives and positives. So you want to make sure that you're doing inverse operations. Over here, when we subtract, it's easier to do keep, change, change. So this would look like negative 14 plus negative 9. Now I know I've got 2 on the same team. I'm going to add them up. I'm going to get a bigger negative, and 14 and 9 is 23. So my answer will be z equals negative 23. This takes 3 lines to show your work, and this is what I'm looking for as far as showing work goes for you to get credit. The next example we're going to do is number 26. Right out of the textbook. 8 plus y equals 12. Now, we need to get y by itself. And because we're trying to get y by itself, the thing that's preventing that is the 8. So we have to take the 8 and we need to move it to the other side of equals. But this 8 is positive. So the opposite of a plus or a positive is a minus. So we're going to subtract 8 from this side, go across the equals, do minus 8 on this side, draw your line. You're going to do 8, take away 8, and that cancels. Bring your positive y down, bring your equals down, and 12 plus a negative 8, or 12 minus 8 is 4. And there is your answer for number 26. We're going to go back and take a look at number 24. 24 is x minus 3 equals negative 14. Trying to get x alone, but this is a minus 3, and we need to get rid of this minus 3 by doing the inverse operation. The inverse of a minus sign or a negative is a plus sign. So we're going to add 3 to both sides of equals. These go pretty fast. Remember, negative 3 plus 3 gives us 0. That's why we're canceling. They have to have opposite signs. And then negative 14 plus 3, the negatives are going to win. Take 3 away from that, you get negative 11. And our last example that we're looking at is number 27. Number 27 says negative 7 plus y equals 13. So here we've got a negative 7 that's standing in the way because we want y by itself. So we have to move that negative 7. And to move that negative, we have to do the inverse, which is plus 7 on both sides of equals. Draw your line. Negative 7 plus 7 is 0. Bring down your y, bring down your equals, and 13 and 7 is 20. Go ahead and try those practice problems that I assigned for you. Check your answers and progress forward. Contact me if you have any questions.